This chart compares the carbon footprint of generative AI against standard physical benchmarks. Generating just 1,000 images with a model like Stable Diffusion pumps out the exact same amount of carbon dioxide as driving an average gas-powered car for 4.1 miles. Multiply that energy draw by millions of users, and the cloud-based AI boom is a serious environmental liability. But for major corporations, it carries an even more immediate threat: uploading proprietary data to public servers. When a company pings an external large language model, they lose control of their trade secrets. Through 2024 and 2025, that reality fueled a widespread narrative that Apple had missed the boat. The consensus was that because Cupertino didn't have a flashy web chatbot, they were losing the AI arms race. While analysts focused on web interfaces, Apple was funneling billions into physical logistics. They were quietly rebuilding their entire hardware pipeline to bypass the cloud completely. The first sign of this shift was a massive geographical pivot. Apple accelerated its exit from full reliance on Chinese assembly lines, shifting heavy manufacturing into India to physically scale up a new generation of internal components. This new hardware is built entirely around Edge AI. Instead of sending a prompt to a remote server farm, Edge AI forces the computational heavy lifting to happen right there, locally, on the device you are holding. Apple laid the groundwork for this years ago. The silicon inside modern iPhones and Macs, like the A-series and M-series chips, ships with dedicated neural engines engineered specifically for these local AI workloads. Processing data on a local chip severs the connection to the public internet. It mathematically eliminates the possibility of a privacy leak while bypassing the colossal power draw of a remote data center. Looking closely at this topology of Apple's M-series architecture, you see how unified memory and neural engines interact in a closed loop. The A19 and M-series processors keep all data flow strictly confined to the physical motherboard. For extreme demands, Apple made a quiet tactical concession. They opened up external GPU support on Apple Silicon through third-party drivers like TinyCorp, allowing AI researchers to daisy-chain massive local processing power without touching a cloud server. Running a multi-billion parameter model inside a Mac's unified memory uses a fraction of the wattage required by a traditional server rack. Apple turned millions of everyday consumer desks and pockets into a distributed, highly secure network of independent AI processing nodes. Edge AI has a physical limit. When a user asks an iPhone to generate complex images or parse massive datasets, the local battery and chip simply run out of runway. To handle that overflow, Apple launched Project AC/DC. Rather than buying standard NVIDIA